we went over some basic SQL in the last video in order to look at data that you've received out of HERON. We're going to go ahead and look at some more SQL and hopefully help you understand how to manipulate your data sets better. So this time I'm interested in looking at the CPT codes that are associated with the tonsillectomies in my data set and looking at how old the patients were when they had their tonsil removed. So I've got data view up here, and you can see one CPT code is 42820, and I know that because I scroll over and the variable is tonsillectomy and adenoidectomy. But I'm kind of curious, like, what are all the codes that are in my data set? So that's where the code info view table comes in handy. So select all from code info view, semicolon. Highlight this and click run. So this is the code info table. And so it shows you the different codes, the code labels, the code path. So you see the age. Scroll down, here's some of the CPT codes. It also had ICD-10 codes. So I'm interested in the CPT codes. You can see that there's at least 2 different CPT codes for tonsillectomies. So I'm going to put where, like we learned before, code like, single quote. This time I'm going to use the percent sign, CPT percent. So the percent is a wild card, and it means I don't know if there's anything before the CPT, and I don't know if there's anything after the CPT, or I don't know what comes after the CPT, because clearly I know here that the CPTs have a colon and then a number associated with it. But I'm just not sure what that is, so I want to leave it open so that I get back all the things that say CPT. So I'm going to highlight this and click run. And you see I have multiple lines here, and they have CPTs, the code label, but you see here this code is repeated. I really only want to see it once. So I'm going to use the term distinct parentheses code, and then I also want to see the code label. I'm not as interested in the other columns, so I'm only going to select the code and then the code label. And distinct means that I'm only going to get one per code now. Now this isn't just useful in looking at the code table. The distinct is also really useful when you look at your data view table or patient view table. So now you can see I've got the different codes here, and they all say tonsillectomy. Alright, so now what I'd like to do is I would like to select all from data view. Now I'm going to look at this because it just is always good to remember. So I'm looking for the column code. So I want where code. I have to rerun this to get all my CPT codes. Now when I know the exact code, I can actually say in. I'm going to copy this, and I put a single quote to go around it. That means it's a string, if you're familiar with programming. So I'm going to copy each of these, and it's going to say that it's going to look for any one of these. They can have, you know, one or many, but they don't have to have all of them. Alright, so now I've got my patients, I've got my CPT codes, I've got my start dates, I've got my descriptions. So you see that there are some of these, it's repeated more than once. So I'm just going to go ahead, I'm just going to look at the minimum start date. They might all be the same day. Maybe somebody had a tonsillectomy more than once. So I really just want the minimum date. So the first time. So I'm going to say patient number, encounter. I'm choosing my columns now. encounter number, code, minimum start date, and then I want the variable. From the data view, these codes. I'm going to click run. Oh, we learned about this the last time. I only got back one line. So I need a group by patient num. So my previous query without the group by gave me the minimum start date for the entire cohort, but I want it per patient. So I'm going to go ahead and click run. And now you can see I've got this table. It's not actually created into a table yet, but got the results for all of the CPT codes and the minimum date per patient. So I do want to create this into a table. So create table tonsil date as, and then run that. Now I'm interested, and when I just ran that, I forgot to give my minimum start date an alias. So I'm going to go ahead and type drop table tonsil date, run that. Now an alias is just a new name for this column, so I want to say as surgery date. Now I can rerun and make this table. Now you see when it runs, it says query executed successfully, but it did not change any of the data down here. In order to change the data, I actually have to go ahead and click select all from tonsil date, which is our new table name. Now when I run that, now you can see the updated column name as surgery date. Alright, so I'm interested in finding out how old these patients were at the time of surgery. So I'm going to have to combine this new tonsil date table with our patient view table because that's where their birth dates are. So to do that, I'm going to say select all from tonsil date, join patient view on tonsil date at patient num equals patient view dot patient num. Alright, so what I did here, I'm saying select everything from tonsil date table and then join it on patient view table. So when I say select all from this and join on this, I'm going to get the rows of both tables combined together. And I'm saying to join it on the tonsil date, that table, when that patient number is equal to the patient view patient number. So I'm going to go ahead and run this. It might not be super clear right now how this is going to work, but hopefully you'll see this example. You can also look online to look up SQL joins to get a little bit better of an idea. But now you can see, so what's on the left is the tonsil date table, and on the right is the patient view table, and it's just basically smushed together. So, and you can see that it's patient number 27047, encounter number, CPT code, surgery date, variable, and now I get their patient number again because that was also in the patient view table. And you can see that the patient numbers match. So that's a good thing. So now if I keep scrolling, now I see all of the data that was in the patient view table. So I get their birth date, their death date, which is thankfully not applicable, their current age, sex, language, race, marital status, religion, last name. I'm not interested in all of these columns because I really just want to find out how old the patient was at the time of the surgery. So I can narrow down my columns that I want, but this time I need to put the table first. So tonsil date dot, that's saying choose from this table and then choose these specific columns. So I want patient num, I want tonsil date dot, I really just want the code. I don't even need the code. I just really want the surgery date. And then I'm going to repeat the patient number from the patient view table. That's really unnecessary, but I just want you to be able to see it when I run these queries so that you're understanding that it really is the same patient that's being matched together. And then I want their birth date. And that's all that I really need. To calculate an age at the time of surgery, I just need the surgery date and a birth date. So highlight this and click Run. That makes it a little bit easier to see. And again, the patient numbers, match. And so this is now all one patient. So this is their surgery date and their birth date. So an easy way to do date differences in SQL is to use something called the Julian day. And that's basically the number of days since some arbitrary point in time. And so we're going to go ahead and we're going to put Julian day around our dates. Julian day. Now I'm going to put a comma and enter. And we want to see the date of the surgery minus the birth date that will show how many days difference it was. Alright, so we've got patient number, we've got the surgery date. You know what, I'm actually going to go ahead and add in, I want you to see what the real date is as well. So I can just copy this and put tonsil date, surgery date, and then also show you the Julian day. I'm going to hit enter here. And then I also want to show you the real birth date. Let's highlight this and run this and see if it's a little bit easier to see. Okay, so for patient 4364, their surgery date was May 8th, 2008. That is this many Julian days. And then you see I've got their patient number duplicated. But their birth date is December 9th, 1996. And this is how many Julian days that is. So basically these two days are relative to each other. And so what I did is I went ahead and I subtracted the number of Julian days of the surgery date minus the number of days, Julian days of their birth date. So this really is their age in days. So to convert that, I'm going to say as age in days. So let's just clean that up real quick and I can hit run. It really helps to do things sequentially. So now let's go ahead and add another. I want this age in days converted into years because that's how you typically see an age. So I'm going to copy this. We know that there are 365 days in a year, so I'm going to divide by 365, and then I'm going to put as age in years. I'm going to highlight this and click on run. Alright, so we see that for this first patient, they were 11 and a half, almost 11 and a half years old. So if we look at the actual dates, it goes from December 9th, 1996 to May 8th, 2008. So that is about 11 and a half years. Similarly, it's really good to spot check. So then you can look at the next patient, and we calculated that it's about 10 years. But if we check out the birth date, this one's really easy to see. The birth date was in 2000, and the surgery date was in 2010. So, yep, just about 10 years later. So I do really recommend that you always spot check, the data that you're getting to make sure that you did the calculations right and that you're getting everything as expected. So now that we've run through a lot of that, we don't actually need to show all of these columns. In our final table, we could just have the patient number, the surgery date, their birth date, and maybe the age in years. So I'm going to go ahead and get rid of all of the unnecessary columns. That was really just as validation and to show us how this works. So I'm going to delete the Julian day, the surgery date. I also don't need to repeat the patient number. Hopefully now you believe me that it really did join together based on that patient number, and so it's one patient across a row. Again, I don't need to see the Julian days for the birthday, and I don't need to see the age and days. It just is a little bit, makes it a little bit more confusing. Now let's go ahead and run this and see how that looks cleaned up. Alright, so now we've got the surgery date, the birth date, and the age in years. So I'm going to create table surgery age as. And it says query executed successfully. So the table has been created. And now you can actually see, I haven't pointed this out before, but if you want to browse data, now you can see the different tables that we've made. Minimum height, surgery age, tonsil date. So you can see all these different tables being created. Since you have made tables, you'll want to click Write Changes to save the database, and then you'll also want to save your SQL file. So you'll want to do both of those things. Well, that's it for this video. We'll continue to go over more data in future videos.